Howdy, students. This is going to be the second part of our first set of notes, which is going to be 13.1. This would be considered part B. And this is just going to be a short video that talks about the factors that affect the reaction rate. And again, rate is the same thing as speed here, but in chemistry, we look at concentration, which is capital M for molarity. So the first factor that actually affects the speed of reaction is the temperature, which I think we knew already. If we heat something up, generally it goes faster. The particles with the higher kinetic energy, well, they're going to collide into each other with more energy and perhaps a better positioning. And because of that, they would probably have enough energy to overcome the E sub A, the activation energy. So they can reach the top of the hill faster and they can begin to form products quicker. So if we look at the picture, the cold molecules are moving slower. They will not run into each other with sufficient energy, and we won't produce as many products. Our reaction speed will be slower. Now, molecules with a higher temperature have greater kinetic energy. They run into each other with a higher frequency, with a higher kinetic energy, and they can form products even faster. The second factor that affects the speed or the reaction rate is concentration. If we increase the concentration, we can increase the reaction rate. A couple things to note. In chemistry, when we see brackets, that generally means molarity. And just a refresher, molarity is equivalent to the number of moles divided by the liters of solution. So I'm going to add that too. Moles of solute dissolved in liters of solution. This was covered in last unit, but I want you guys to have that in your notes to refresh. If there are more particles, and when we say particles, this is because we have an increase in moles per liter, there should be a greater number of collisions that are happening, which in return will produce more products. So number one, you increase the temperature, the speed of the particles is going to increase your products. But if we have more particles, that will also increase the amount of products. The third factor is particle size. So if you increase the surface area, this will increase your reaction rate. We discussed this in Unit 12. We looked at how agitation speeds up dissolving rates. If you have a greater surface area, the particles have a greater chance of coming into contact with each other for more collisions, which results in a greater number of products produced, which increases the reaction speed. The fourth factor is the presence of a catalyst. A catalyst is a substance that speeds up a reaction, and it works by lowering the activation energy. So if we look at the pictures on the bottom, we see our potential energy diagrams. And if our reaction starts out here, when I add a catalyst, it takes that hill and it actually pushes it down and it lowers the amount of energy required to produce products, which speeds up the reaction. It is not a product or reactant, and it is not used up or changed itself. So when you have a catalyst, it doesn't get used up in the reaction. It just sits there. The presence alone lowers the activation energy. So in nature, we have biological catalysts, and when we have those, we call those enzymes, which is just a specific type of catalyst. Certain bacteria can be enzymes. We have lots of enzymes in our body. There are also lots of enzymes in nature, and they work by binding to certain molecules. And when they bind to certain molecules, that allows more products to be formed. Now, an inhibitor is the opposite of a catalyst. Specifically, it's the opposite of an enzyme, but it blocks the action of a catalyst. So we have our potential energy diagram. We add a catalyst, it lowers the activation energy. But if you add an inhibitor, it brings that activation energy back up to where it was before.